Journal of Business and Research, which has been listed in UGC Care Group 1. And so he holds a rich experience, and his interest area caters to statistics, analytics, and research methods. And he has been a vivid researcher and has published more than 16 papers in various international and national journals of repute, including ABDC listed journals. And also he has presented various presentations in the international and national conferences, and has actually got 9 best research paper awards. And he has been conducting various kind of projects. And along with that, he has undertaken 36 sessions as a resource person, which is a good amount, including the one which has been sponsored by MHRD and various workshops. And he has been associated undertaking the FDPs with Hansraj College, Sri Ram College of Commerce, and various other B schools. So again, sir, you're most welcome. Over to you.
Thank you very much, Vijayalakshmi ma'am. You're also a learned colleague of mine, and it's really an opportunity. Thank you to the whole organizing team, Aarti ma'am, Parul ma'am, Vijayalakshmi ma'am, Abhishek sir, Ramya ma'am, for giving me this opportunity of taking a session in this refresher course. And welcome to my esteemed colleagues and fellow faculty members who are participants in this program. So it's always a different experience to interact with fellow colleagues in these kind of research and refresher courses, because normally we mostly interact with students, but this time we are interacting with each other as colleagues and as learned professionals. So thank you. And with this, let me start the session. So I hope my slide is visible.
Yes, it is visible.
Okay. So basically, please feel free to write or raise your hands and let me know if you have any queries, because so that we can discuss in between. So today's session is on interesting topics and new developments that have taken place. In fact, this entire refresher course is being conducted in that background. So in the field of finance, there are many new developments that are coming in, and many of you who are teaching or researching in finance would know that finance is more of quantitative in nature and is more empirical and data based and analysis based. This is evident in the way we teach finance and also the way we do research in finance. So there are 3 key things that have emerged over the years: financial modeling, financial econometrics, and financial analytics. So I would like to dedicate today's session on these 3 themes, on their introduction and what they are and what is their focus areas, what is their applications, what are their requisites, and what are their methods that are there. Obviously, we have limited time, so I will look to give you a good introduction regarding all these. And then I would also provide you some good references and direction to get started with. So we all know that in the field of, in today's time, if you look in generally also, the decision making in the wider field of management and commerce has switched from, there was an entire generation, there is an entire generation still who is making an entire decisions based on subjective judgments, intuitions, gut feelings. It's not to say that those things have not worked out well, but you see that entire decision making in today's time has shifted to be data driven, analytics driven, Analytics is able to provide those deeper insights. You also see that in reflection in the emergence of the fields of data science, analytics, machine learning, and all these things. So these fields have emerged wherein the decision making in commerce, business management is more linked to data science. Yes, Parul ma'am, anything?
Yes, sir.
Okay, okay, no problem. I thought you wanted to say anything.
No, no.
So, okay. So the data-based decision-making approach that has come up in modern times has gone into every field. If you see in marketing, there is now marketing analytics, HR, and even in HR, you will see HR analytics, and in even in the recommender systems that we use. For example, you look into any product on Amazon and you find several similar matches. You log into a movie or a show on any OTT platforms like Netflix, Amazon Prime Video, and so many Hotstar, so many Indian and foreign platforms, and you see many similar shows coming up on your even if you order some grocery, you see similar items. So all of this is based on data and insights from data. So the field of data science and analytics has increasingly come up, and not just for behavioral, not just for quantitative and mathematical and engineering and natural sciences, but also for social sciences. For the first time, there is a wide scale integration of social sciences with data science analytics. And in this wave, there is also the commerce business management field in broader level that is getting affected. So you see, you nowadays you would not wonder if a political science student is learning R programming, or if a film studies student or language literature student is learning Python. So all this level integration is happening. And in the same way, all these fields have also come into finance, also come in contact with finance. So we have, this has led to emergence of these areas: financial modeling, econometrics, analytics. Another in the background, I would also like to say that there is now availability of data on a large scale that we call big data. So the data was available at best at sparse frequency. Now the data is available at a huge frequency. For example, if again I take example from retail and marketing businesses, so you see there are every day there are millions of transactions that are happening on digital payment platforms, on online OTT platforms. Simultaneously, there are techniques to analyze those data that has been developed over the years. It perhaps techniques were there for a long time, but there was not availability of data, and there was also not availability of computing power. Now there's another big thing that has happened apart from data, is that now there is computing power available. So you have speed. I remember 8 7 8 years ago, about 10 years ago, when I started doing my research post my PG, we had some few limited softwares available for data analysis, which were not customizable, and they were all licensed versions. We had to run from pillar to post to get access to those softwares and then carry out some analysis. This was 10 years ago. And softwares in finance domain, you would know, which have been used traditionally, like eViews or Stata. In other domains of marketing and human resource, we have used softwares like SPSS. So SPSS or this smart PLS and all this. So now there are open source softwares available. So Excel has developed much more in terms of modeling capacity, and now there is emergence of R and Python, which are open source software, and in which you can download any kind of package or from library in Python, and you can do analysis. So now the this transformation, you would wonder why is it taking place now? Because now the big data is available, and now only we have developed computing power. It's just like you see, we always wanted to go outside our Earth into other planets of solar system. but only when we have the resources, we have the means. That plan was always there, and the planets which we want to explore, like Mars, is also there. But when we have the resources, we have the technology, only then we can implement it. So similarly, when we have the data and we have the computing power to analyze those big data, are these things emerging. So with this background, let me now specifically, this background was slightly general also. Now let me specifically talk about financial modeling, econometrics, and analytics. So many of you might be confused if you have heard about these three. Then you might be confused. I was also confused, and there is no clear-cut demarcation that this is what financial modeling is, this is what financial econometrics is, this is what financial analytics is. And in fact, you will see that there are several books and learning resources in which, for example, financial modeling would include econometric techniques also, or financial analytics would also include some econometric techniques or modeling aspects. So there is no hardcore red line and bifurcation that these three are distinct in this way, and it is very difficult to segregate, because modeling means all kinds of modeling. Many of you would know it also includes econometric modeling. It also includes some kind of analytics, some kind of modeling technique that is used in analytics that can also be called modeling. But still, there is some bifurcation, and approach is particularly different. Techniques may be overlapping. For example, you will find that maybe a multiple regression technique is being used across the three, but the approach or the intention or the purpose with which it is being used is very different. And that differentiates the context, and that provides the background. So let me start with financial modeling. One by one, we will explore these things. So basically, I would say that a financial model establishes relationship between financial variables through a spreadsheet like function like MS Excel, and that can help in addressing business problems, financial problems, and forecasting. So for example, the standard three statement financial statements that we develop, which are interlinked. So in sheet one, we have the P&L, trading and P&L account. In sheet two, we have balance sheet. In sheet three, we have cash flow statement. All the three are interlinked, and then we can carry out scenario analysis, sensitivity analysis. We can do forecasting of key financial ratios based on past statistical trends or based on management forecasts. So developing this kind of Excel-based model or spreadsheet-based. Excel is a product, but spreadsheet is the more generic term. So spreadsheet-based forecasting of financial variables, accounting variables of the company using interlinked models, that has been probably the key focus of financial modeling. And that's why you will see in the industry, when we talk in the industry about financial modeling, that's what the focus is. And in fact, there are some professional certifications also available, like financial modeling and valuation analyst certification from Corporate Finance Institute in USA. And there are 3 levels of financial modeling certifications available from Financial Modeling Institute in Canada. So there is Associate Financial Modeler, there is Master Financial Modeler, there's Chartered Financial Modeler, and Master Financial Modeler. These 3 level certifications are available from this FMI, Financial Modeling Institute, which is based in Canada. And there are also many local certifications going on in financial modeling. And across the board, you will find that the consensus is that spreadsheet-based analysis and forecasting of financial statements and their modeling and their incorporating the assumptions about revenue, expenses, developing an interlinkage between them, and incorporating various factors, finding out true ratios and duo-pont analysis, which we teach basic ratio analysis and other, developing these kind of common size and index numbers based trends for financial variables. So all this has been the focus of financial modeling. And also, again, related to this, in financial modeling, you can also think of corporate finance issues like capital bursting decisions, capital burst evaluation. We have the project cash flows, so evaluation of them, and using different methods like NPV, IRR, that can also be part of financial modeling. In fact, that is a proper part of financial modeling. Then capital structure decisions, that also evaluation of different capital structure choices that we do in leverage, and the leverage analysis, EBIT, EPS analysis. All this can be also considered part of financial modeling. So all these exercises which are related to a company's financials, which are carried on through Excel or spreadsheet based applications, these are essentially the core thing of financial modeling. That is the general understanding, and this has been going on for a long time now. There's a consensus around this, and this is very important if you want to develop the skill set of students, because when they go on, and whether they go on to do some equity analysis or corporate analysis or company risk evaluation or many other roles, job titles can be financial analyst or functional analyst. So in those job titles, there is heavy use of Excel and Excel based modeling. That's why they are very popular also among students from employability perspective. So foundations of this is basics of spreadsheet and finance functions in Excel, and the concept of time value of money, that is the central concept we all know in finance. And then applications is financial statements forecasting, cost of capital, capital bursting decisions. Yes, and another one, another two things, sorry, I missed. What is the financial analysis of leasing and hire purchase decisions? So those who have taught or covered these topics in classes, I got to cover this in one of the semesters at Ramanujan College. So this is also very interesting thing, and it is quite similar to the capital budgeting framework that we use. So leasing and hire purchase decision evaluation, and the major application that I wanted to discuss with you is the valuation part. So valuation of equity and firm valuation. So apart from the spreadsheet and applications part, this equity and firm valuation, that is a very important part of financial model. So we have all those, and this valuation, as you know, is the key pillar not only for mergers, acquisitions, wherever from time to time there is need for raising capital or even presenting the true and fair picture to investors, shareholders. There is time to time the need for valuation for a company. So equity and firm valuation, we know there are different models: free cash flow to firm model, cost of capital model, adjusted present value approach, and then there is different levels of decision making. For example, in dividend discount model for equity valuation, we have constant growth, constant dividend, then varying growth rates, and then constant growth rates. So we have different models, different types of situations and models. So this equity and firm valuation is there. And in financial statements forecasting and analysis, as I told, there are good advanced topics like sensitivity analysis, scenario analysis. So all of them are also part of this financial modeling. And further, if you look, then security analysis, then bond valuation, bond yields, duration, equity returns, and risk adjusted returns, that also can be done. As you know, many of them can be done again using finance functions itself. Then in portfolio management applications, we have the construction of portfolios, we have port efficient frontier, we have the variance covariance matrix, calculation of portfolio risk and return, portfolio optimization. Like some of you, if you have been teaching decision sciences or quantitative techniques, you would know that optimization and linear programming problems need to be in real life. We need to address them through softwares like Excel. So similar to that is portfolio optimization. So portfolio optimization is a very interesting and fascinating activity. So portfolio optimization can also be done using spreadsheet, and these all applications will be within the purview of financial model. Then in investment and retirement planning, we can see the effects of, we can develop financial models for different purposes. For example, we can develop a comprehensive model in which we can take into account various situations. For example, what if the rate of return that we are anticipating, so we have a 20-30 year window. So what if the rate of return that we are anticipating changes, increases or decreases, or our savings increases or decreases? And you all know that the real currency and nominal currency is on the basis of effect of inflation. So we know that the real currency is after removing the effect of inflation, and nominal currency is including the inflation amount. So the difference between the two, planning in real currency, because someone will like that they have the same purchasing power after 40 years as 1 million rupees has today. And having a nominal 1 million rupees is a different thing. And having 1 million rupees with same purchasing power as today is a different thing. Because in 30-40 years, 1 million rupee can buy today will not be the same what 1 million rupee can buy after 30 years or 40 years. Then portfolio restructuring can also be very easily done using these models that we can develop. And even in the derivatives and options field, so binomial and Black-Scholes pricing models, and then option Greeks and real options. So again, real options for evaluation of capital budgeting and investment decisions. So for all these, we can develop a model. So what is essentially a model? Let me bring you back to this. A model is something which is a replica of real life. And once you develop it, you just need to fit in some values. And as you fit in the values, all the other outcomes change. And all other outcomes change and they behave accordingly. So you need to develop such a structure that you change one input and all other inputs change accordingly. So if there is a, before I go to financial econometrics, I will stop sharing for a minute. And I would like to share with you a financial model that I normally discuss with my MBA students. So just give me a second, I will share with you. Meanwhile, if you have any queries or doubts, you can please post in the So this is a financial planning. Can you see my screen? The Excel screen?
Yes, sir, we can.
Okay, thank you, ma'am. So this is a financial model that has been developed. So this is a very comprehensive retirement problem thing that we take up. So somebody is 30-year-old now and wants to have enough money equivalent to 1 million after all taxes at the age of 65, and this is the anticipated inflation, and this is the amount of return that he's going to expected to generate through investments. This is his initial $1 lakh is his or her initial savings that he wants to put in, and this savings is expected to grow at 2% because his salary and other income will increase over time, and this is the tax rates and everything, and inflation will average is expected to average around 3% over the long run period. So what amount should he start saving to get this 1 million after all taxes in real terms? Real terms meaning that what is the purchasing power of $1 million today? She should have the same amount, which will have the equivalent purchasing power after 35 years, so that he can consume same amount of products and services as what $1 million can buy today. So for this, we have developed a model. And in this, the beauty of this you can see is that this has been developed as a model. So if I change the inflation rate from 3% to 3.5%, your entire calculations automatically update. And if I change it, you can see entire calculation will automatically update. So this has to be developed. There is obviously a series of formulas, interrelationships, and everything is linked to each other. So, but this is the beauty of this kind of model, that you can change any input. For example, somebody is coming to you at not at the age of 30, but at the age of 25. Then your calculations will automatically get updated. Somebody is coming to you at the age of 35. Somebody's retirement age has been, government is looking to increase retirement age as India's population pyramid becomes inverse now. By 2050, there is going to be 20% people above 60 years. That is going to be a big burden. So a good strategy is to increase the retirement age. So maybe some of the young ones, by the time we retire, retirement age is increased to say 70. So this calculations will automatically update itself. So this is the idea of creating a model, so that inputs can change, initial savings we can change, and we can have $1,60,000 as starting, and we can have the target balance as 1.5 million. So accordingly, everything will change. So the idea behind developing a financial model is to do something like this. Okay, so that was my discussion regarding financial modeling. I hope I have given you an example and introduction of, and it's conveying its applications. Now, I will briefly cover financial econometrics, because many of you who do research in finance would already be aware of financial econometrics, and today's session is also primarily on financial modeling and analytics. So I will pass over this quickly. So financial econometrics, as we know, is the application of mathematical and statistical techniques to problems in finance. So basic purpose and basic approach, again, because especially financial econometrics and analytics will have a lot of things overlapping. A lot of techniques you will see in both modeling, in both analytics and econometrics. But in econometrics, the approach is to establish relationships, to test theories. So for example, in economics, we have, for example, my PhD thesis was on macroeconomic variables and their impact on stock market. So there are many macroeconomic variables: inflation, interest rate, GDP, industrial production, oil prices, exchange rate. So how do these variables have an impact on financial markets? That was my thing. So testing relationship, testing theories is the primary purpose. The techniques may be similar, but the primary purpose in financial econometrics is to test theories, relationships, establish, try to find out what is there in the real life. Also, forecasting is also there, but that is also a part of it. The primary focus is on establishing relationship, testing hypotheses and theories, examining the effect of one variables or one set of variables on the other set of variables. That is the primary focus and intention, and that is what we do mostly in academic researches. And that is why in academic researches we heavily use financial econometric techniques. Like all these techniques you would be aware of: correlation, causality, co-integration. All these techniques we use. You can see this correlation, regression, granular causality, impulse response, variance decomposition, co-integration, ARDL model. So basically what we are looking to do is to check the lead lag relationship. Because of financial and economic variables, some variables occur in advance and their impact is visible to us after 1 or 2 quarters. So for example, there is a big investment today, but the employment and the output and the economic outcomes of that will be visible after some time. Exchange rate depreciation or rupee depreciation will have a lagged effect on inflation, because what we are receiving today is the orders we placed 3 months ago, especially for foreign transactions, for foreign import and exports. So if the rupee is depreciating today, its impact will be visible in the next quarters. So we have this lagged effect in the field of economics and finance. So in fact, in business also. So impact of lags, the past values, the contemporary values, and then this IRF is how much of a shock. There's a sudden shock. For example, in March 2022, Feb and March 2022, due to Russia's invasion of Ukraine, there was a huge spike in oil prices. Oil went to a record high of $129 per barrel. Now it is trading at about $70 per barrel. But at that time, it had gone up to $129 due to a sudden shock. So what is the impact of shock? That would have an impact on the markets. Or we know this, oil prices will cause inflation. Inflation will cause interest rate hikes. Interest rate hikes will cause the the investments to slow down, the consumptions to slow down, and that will have a negative impact on long run profitability and revenues of the companies, and that will have a negative impact on stock returns. So there's a channel through which they function, and because of this channel, things happen after some time. So lagged effects, and basically the cause and effect relationships. And in the short run, that is in the immediate purview, and in the long run, when we allow all variables to vary, not worrying about the concept of stationarity or removal of time trend, when we allow the variables to vary as they move, as they are going on, we allow them to go on in the following the time trend. So long run and short run relationship, contemporaneous relationship, cause and effect, causal using lags. So all these topics and their methods and techniques have been the area of financial econometrics, and huge huge volume of researches on these techniques and in their applications, because financial data particularly has been available throughout. So, and these techniques and through softwares has been also available. So these techniques have been implied in the academic researches. And as I told earlier, In academic research, our primary purpose is to explore the relationship and test theories and to establish that this impacts this, and to develop the body of knowledge and to give policy prescriptions and to give long run advices to management. So from that perspective, these techniques are very useful. So some more examples that we can see of these techniques is that are the financial markets efficient to test whether we all know about CAPM and APT theories in finance. So CAPM is the capital asset pricing model, APT is arbitrage pricing theory, then volatility, then what is the determinants of bond credit ratings? What is the determinants of sovereign credit ratings? So countries are also having the securities issued by countries also get credit ratings. What is the determinants of credit ratings issued by the countries, by the local companies? What is the determinants of real estate prices? Then long run relationships modeling between prices, exchange rates, between different financial markets, hedge ratios, trading rules, then testing spot or future market relationships, testing the hypothesis. So we all know that announcement of earnings and dividend decisions, what impact it has on the financial markets. So all these things we need to factor in. Also, the markets are correlated amongst themselves also. So you can see that the market, for example, whenever the developed countries markets rise, then there is a positive impact on Indian markets. And due to the timing, you almost know that what has happened before the starting bell rings in India, you know what has happened in the Western markets. And if there is a negative sentiment there, you can almost be sure that Indian market will also open a little down if there is a clear-cut selling across the board in developing markets. So there's a huge correlation between, and there's a great impact between the markets, and due to different time zones, we know in advance before our trading session. So what is the interlinkages between markets? So all these things can be explored using financial econometric techniques. And financial data varies from the traditional economic data because, for example, stock prices are available every second. And quality is not an issue because nowadays we have the completely transparent electronic trading, and there is no issue of quality or manipulation. Completely transparent way they are reported and provided, and that is the basis of the entire market. And people are taking their all lifelong savings in the financial markets, so they know that they can be trusted. But financial data is also a little noisy because there is too much information. So sometimes when there's too much information, you cannot hear the real thing or the relevant thing. So there is overload of information, and there are many random and sporadic events that also impact the movements of financial assets. But we need to segregate those from the long run and permanent and more stable and more meaningful patterns. So noisy is the disadvantage because too much information makes it crowded. And in that crowd, most of the things may be irrelevant and temporary. And we all know that financial data does not have normal distribution, and compared to economic data, the frequency is much more. The tools and methods of analysis is much better, but financial data is noisy, but also free from errors and data revisions. So a lot of times the questions are raised that how GDP is calculated, how inflation is calculated, whether those things are reliable or not, especially for countries having opaque systems like China. There is no transparency as to how the data is recorded and reported. So measurement mistakes and revisions is a problem. So, but that is not a problem in the financial data. And also, we all know that the types of there are three basic types of data, which is cross-sectional, time series, and panel. So if units of study is the companies or individuals or nations that we are talking about. So if the units of study is many and we are analyzing them at a single point of time, then it is cross-sectional data. For example, for the year 22-23, you are analyzing the data of 500 companies, companies listed in BSE 500 companies. So this data is a cross-sectional data because there are many companies numbering up to 500 and you are taking them for a particular year. So this is cross-sectional data. Units, again, I mean companies, individuals. For example, in behavioral sciences, we take survey. In social sciences, we take survey. For example, if we ask people how much, which kind of, common people, if we ask what movie genre they are interested in, and we take survey of 10,000 people across the demographics of India. So those 10,000 people will come under, with this study will be a cross-sectional study. Similarly, we take survey of investors, we take several companies, we take data of several countries. So we take data across industries. So when units of study, individuals, companies, industries, countries, economies are many, but all of them have been studied, examined at a single point of time, we are talking about cross-sectional data. And when there is a single unit of study, which is being observed over time, then it is a time series data. So for example, you are studying the financials of a company, single company. If there is multiple, then it will be different. Single company, single country, single individual, single portfolio, pattern you are studying over the years, over time, then it is time series data. And when both units of study and are multiple and you are studying them over time, then it is panel data, a panel of data. So for example, in my PhD work, I studied the patterns of several stock indices. And in the several stock indices, I took them over years, over 2 decades. So there is panel because there are several stock indices. So there are several units of study. And since I'm studying them over 2 decades, there is over time. So it is a panel of data. So you need to understand these three things. And within panel also, if the time component is long, then we call it long panel or time series panel. And if the cross sections are more, then we call it the short panel or cross sectional. So this is the thing. Then for developing a standard financial econometric model, we first start from theory. We first start the idea from theory, which comes from our previous literature and body of knowledge in that domain. And then based on that, we formulate an estimable theoretical model. And for that theoretical model, we collect data. So theoretical model should specify what are the variables. And for those variables, we collect data, then we estimate the model. And if the model is statistically adequate, that is, it meets assumptions, then we go on to interpret it and use it for further analysis. If it does not meet the statistical assumptions, then we need to reformulate it because there may be different problems. You may have missed out on some important variable. There may be, if you have missed out on some important variables, there will be different problems like autocorrelation or heteroscedasticity. If you have incorporated too many similar variables, then you will have problem of multicollinearity. Then and if you have not, if you have taken the relevant variables but you have not presented them in the right way, for example, population GDP should be taken as log. We should take log of GDP, log of population, and some variables should be taken in ratios. So for example, money supply should be taken in ratio as a percentage of GDP. So if you have not done that, then your model does not have correct specification. So in that case, you need to go back and reformulate. So now I will start with the last part of the session, which is financial analytics. And for this, I'll just take a minute and then we'll start. Meanwhile, if you have any queries, you can ask. Okay, so financial analytics, and don't worry, I will share this entire presentation with you. But let me remove this annotations. So is my screen visible, I think?
Yes, it is visible.
Okay, thank you, ma'am. So now let's talk about the latest thing that is there in the picture, and it is called financial analytics. So application of analytical techniques, primarily which are also statistical as well as which are developed from computer algorithms to the problems and field of finance, is what we are talking in financial analytics. So in financial analytics, we are looking at several problems that, if you look at this, then the perspective is different. So here we are now looking at problems which are more about prediction and forecasting. So for example, in financial analytics, you will be looking at problems like, is this customer a good credit risk? Is this company a good credit risk? A classic financial analytics problem that we try to decide what is the probability that a particular person or a company, based on their financials and other records, will default if we go ahead and give them the loan. Especially similarly, which kind of customers in the banking and financial services industry, out of the entire database of millions of customers, which are the customers whom we should target, whom we should approach for providing, say, credit card or loans, offer loans, personal loans? Whom should we target? Because you all must be receiving some calls from credit card, pre-approved loans and credit cards, but use of analytics will greatly fine-tune this, and it will enable much more targeted approach. Similarly, there would be much more applications. I would discuss about that. But for example, another major application of analytics is to develop algorithmic trading. So computer-based trading rules you have developed. So even when you just need to have a good internet connection and leave it at that, even when you are partying and holidaying in some other place, your money will remain invested and it will keep growing because you have provided the right set of trading rules and instructions to the computer. It will automatically execute. Strategy you will have to formulate, but the means of implementing those trading and investment strategy is now available to you, and that will get automatically executed. So algorithmic trading, many people have gained a lot using algorithmic trading, particularly when done using options and other derivatives. So financial analytics is use of cutting edge technology, algorithms, along with statistical models and techniques to financial data and investment problems and corporate problems, corporate finance problems. So you need to be good in these three things, because this field, as you know, is an amalgamation of different things. So first of all, our primary subject matter, which is the knowledge of finance and investment, needs to be good. Then some basic statistics and mathematics you should have, you should be aware of. Though what I have seen in industry and real life is that after a certain level, the use of statistics and mathematics, when you are playing on the field, and when you're doing things in real life, use of statistics and mathematics takes backseat. So, but still, the more knowledge you have, it is better for understanding, developing the understanding and developing insights. So subject matter is important, and then coding is also very important, because you will be able to execute those commands using R, Python primarily. In fact, by many of the things, if you want to do some analysis, statistical modeling, then R is preferable. Otherwise, if you want to go for cutting edge things like machine learning, algorithmic trading, then Python is good. And don't fall into the Gigo trap. So Gigo trap is garbage in, garbage out. So mindlessly don't put anything into the software, whether R, Python, because if you put it like that, then you will get irrelevant outputs which have no relationship. You will have predictors which have no meaning. You will have results which have no practical utility. So you need to apply your mind as to what you are trying to gain, what you are trying to know, and what you are trying to provide as input. So before this, I would like to tell you about a little bit about machine learning and artificial intelligence and all that. So machine learning is basically, and in fact, before machine learning, I would like to talk about artificial intelligence a little, because artificial intelligence is the biggest thing. So see, basically, we are all intelligent beings. We as human beings have our natural intelligence of varying degree, and over life also our intelligence changes and evolves. And nowadays there are a lot of other types of intelligence also. It's not just traditional mathematic or arithmetic intelligence. It is emotional intelligence, it is visual intelligence, many other some people say there are 8 or 9 types of intelligence. So when we see that intelligence when we try to pass on that intelligence to machines and softwares, then we are talking about artificial intelligence. For example, when we see a person, then instantly, due to their facial pattern and the face features, we recognize that this person is Mr. X or Miss X or Mr. Y or Miss Y. So if we pass on that power to computer software. For example, there is face recognition softwares. In front of them, if you go, they recognize the pattern of your face and they will say that this is Miss Kamna that is coming here. So, and that is that is going to be the most prominent way of doing things in future, because nowadays signature and fingerprints are not going to work. Face recognition and fingerprints is going to be, and biometrics is going to be. In fact, in our whole Aadhaar card system is built on biometrics. So there is technology that, like human eye and mind coordination, when we recognize another person by their face, similarly, eye and mind coordination, that intelligence we are passing on through programming to a software. So this is one example, face recognition. Similarly, voice recognition. The way we speak, everyone's voice is little different, and how they pronounce things is little different. So based on the pattern, they can recognize, machine can recognize that this is the voice of this person. So voice recognition, face recognition, fingerprint and all is already a very common thing now. So this intelligence, which was earlier only with human beings, is now being passed on to machines. And there are many other areas of artificial intelligence. I am starting with artificial intelligence because artificial intelligence is the broadest of all these things. As you can see, the biggest circle is of artificial intelligence. Within that, everything else falls. Long back, artificial intelligence or AI-based computers or bots defeated the planet's smartest human being in chess, in game of chess. So it's not that these are just manual things. Game of chess, it's a very completely strategy and planning and analysis based game, intellectual game. Even in the game of chess, long back, the AI bots have defeated the #1 chess player on Earth, the best human being for chess. So this type of intelligence has gone, to different level. We also have IoT, Internet of Things. So you are going for work, and before you come back for work, you find milk at your doorstep or eggs at your doorstep. How? What has happened? While you were working at office, the camera in your fridge automatically detected the level of milk and eggs in their respective slots. And they found that eggs are too few or milk is too less. And it automatically connected with the ordering message, and a message order was sent to the local grocery shop, or order was placed through software. And the local grocery shop delivered those milk and eggs. And you can even give payment control. So payment can also be done. And before you reach home, your milk and eggs and bread and whatever you need is lying at your doorstep. So artificial intelligence is going to deeply, and this 5G rollout, you must already be aware that 5G technology is now in India. It is rolled out. It will take time, 6 months up to 1 year to stabilize and be available at mass scale like 4G or 3G. But all these things will be supported by 5G technology. So artificial intelligence, if you think from chess perspective, and there are many things. Self-driving cars. In Europe, a fleet of trucks pass through very difficult to navigate hills. A fleet of entire trucks pass through a very tough terrain through hills, crossed the border of countries. And that entire fleet of truck did not have a single human driver. They ran completely based on software technology that is there. So self-driving is also an application of AI. They can, just like driving requires human intelligence, to be able to see something coming and everything, the logistics of road. So similarly, that was there. So AI is widespread, great utility across the domains. Now, when we are talking about the field of business and commerce and finance, then we are looking at the applications in machine learning. So what is machine learning now? Machine learning is that your algorithm learns from the patterns. So for example, it learns from the patterns of past data, that who are doing well, who are responding well, who are more likely to buy. So for example, it looks into the pattern of consumers and investors and financial investors and shareholders and finds out who are the good targets, what characteristics qualify some individuals as more approachable and for as individuals for whom the outcome is more likely to be positive. It also in investment field, if you see which kind of investment strategies are going to bear more fruit, which kind of investment strategies, like you see there are so many option trading strategies, so which kind of investment strategies are going to give more returns and lesser risk on most cases. What will happen in real life is this cannot be predicted with certainty by anyone. Nobody can claim that. But which is the most likely strategy to give good returns and minimize risk? So machine learning applications can help in discovering these things. And the applications that I talked about of facial recognition and voice recognition and image recognition, they come in deep learning because they, your face is bifurcated to the minutest detail. So they will say that this is a match or this is not a match. Data science and machine learning have a lot of overlapping. Data science is application of statistical techniques. Data science is more similar to econometrics. So application of, again, predictive techniques, statistical predictive techniques to the field of business, commerce, management, and social sciences through this kind of, softwares like which can handle big data. For example, in elections now, in India, there's huge population and not all are online, but in elections related to board meetings or shareholder meetings or small groups, they analyze the pattern and they try to find that which voters should we really approach, because there is marketing cost and there is advertisement cost. So which are the more likely voters, which demographics are likely to yield more favorable votes for us in any kind of election versus which kind of other groups which are not so going to change their stand. So everywhere now data and data science is being used. In healthcare industry, data science is heavily used now. So which kind of patients, for example, during COVID, which kind of patients are more vulnerable to ending up getting in ICU or critical stage due to COVID? So based on data, it was identified that patients with comorbidities and patients above a particular age, it was a consistent pattern across nations that these are the age groups and these are the patient criteria which are very much vulnerable. Still, unfortunately, there were deaths of maybe young person who had no comorbidity. That cannot be explained. So telling that person with comorbidities and above a certain age are more vulnerable doesn't mean that somebody who is young and has no comorbidity cannot end up being seriously ill due to COVID. But which are more likely, because that provides much more greater insights to us. So data science and machine learning being quantitative techniques and are being applied across the board in healthcare, social sciences, marketing, advertising, digital media. And in fact, for example, there is a field called text analytics. So text analytics is also used in accounting for analyzing companies' financials. And it is also used in, say, for example, for political purposes. So before a political rally, you find out the users from that area based on their geographical location and see what is the trending topic, what is the hot issue in that area. And then the analysts give input to the political leaders that these are the issues which are hot, which are relevant now. So those issues are deliberately touched upon in the election rallies in that area, because issues may be local and they may vary from state to state. So those issues, those sentiment of people, there's also a technique called sentiment analysis. So all these things, even the social media posts are being analyzed for political purposes. So data science, machine learning is being greatly used in all these endeavors. And machine learning techniques can be supervised or unsupervised. So supervised is basically when we are trying to predict something, and unsupervised is something when we are trying to find a pattern or correlation. And so data science is basically, there are three fields: computer science and IT, maths and stats, and domain or business knowledge. So if you look at the intersection of domain knowledge with maths and stats, which is traditional research, domain knowledge with maths and stats techniques, we have traditional research. And this traditional research will be primarily our techniques like financial econometrics. Then if the domain knowledge goes with computer science and IT, then we have this entire software, IT and IT-enabled services industry. Then they go into software development. And when this domain business knowledge, computer science techniques, and maths and stats, computer science softwares, algorithms, and maths and stats, all three converge, then we have the field of data science. Here you have domain knowledge also, like I told you earlier also, for financial analytics, you need finance investment knowledge, software, R programming, Python programming knowledge, and knowledge awareness of maths and stats techniques. Then you have analytics or data science domain. And if it is only computer science and math stats techniques, then it is machine learning. So these things are there, and we can go on and on and on in this, but in financial analytics, again, we use data through information technology and techniques to make business decisions. So some of the applications I have already talked about: sentiment analysis, algorithmic trading, asset price prediction, portfolio evaluation, investment advisory, and robot advisors, and chatbot digital assistant that you see on websites. Then text analytics for qualitative data, for example, the annual report of companies. So we can do some text analytics on that. Then derivatives pricing, interest rate, fraud detection, while underwriting. So if the risk is high, so underwriting means deciding at whether to give loan or insurance to a particular case or not, and if yes, at what rate. So in that, you take into consideration the past record and the probability of default. If the probability of default is too high, you may not lend at all. And if it is less, then you may lend, but still with some conditions. And tax compliance and money laundering is also detected. So many people you would have heard nowadays that they are they are spending money abroad, and they are holidaying, and they are buying some new vehicles. And based on that, the income tax department is, based on their social media posts, income tax department is able to catch those people. So there is analytics working at all places. All your bank accounts are linked with PAN card. and you're all, wherever you do, whatever you do is, there's a huge net that is around you, and that can be detected. Any inappropriate income or expenditure is immediately caught. Trade settlements and blockchain and fintech, cryptocurrencies and fintech. So blockchain helps. A very good application of blockchain is in safeguarding documents. For example, you may have heard about the concept of DigiLocker. So in DigiLocker, blockchain technology is used to secure documents and certificates. The certificates that you will get from Ramanujan TLC programs is protected and secured by blockchain technology. Cryptocurrencies you are already aware of, and fintech we all use in our daily lives, Paytm, Google Pay, and all those companies. The technology we are using, which in instant moment we don't even need to take out cash and count it. Within seconds we are making digital payments. So this entire fintech is there. And since time is approaching to end the session, finally, I would like to give you some references for all these. So for financial modeling, you can use a traditional book, which is Financial Modeling Using Excel and VBA. VBA is now outdated, but it provides good. Excel part is good, by Chandan Sen Gupta. And the latest one is by Simon Bennings for Excel and R. Then for financial econometrics, two standard textbooks, because it is a well-established discipline: Basic Econometrics by Gujarati and Introductory Econometrics for Finance by Chris Brooks. And now this Chris Brooks book not only includes EU's interface, it also includes R and Python interface. Then for learning R and Python, a very comprehensive book I found is Data Analytics with R and Python by Dr. Bharti Motwani. She is an Indian author. And for business analytics and machine learning, these are some good references. And for finance foundations, you can have these books because you should recommend the standard textbooks for finance, like Briley and Myers for corporate finance, Bodie and Marcus Kane for investments, Hull and Basu for options. And for analytics, financial analytics, you can have these books: Mastering Python for Finance and Python for Finance, Financial Modeling and Quantitative Analysis. But these are not, these are what I have found, but all these are constantly evolving, and these are all coming up and growing. So this is a new field. So you will see many more latest additions and interfaces coming up. So thank you, everyone. That's it from my side. I am now open to queries and discussions from you all.
So any queries can be posted here in the chat box. So everyone is actually praising the wonderful session.
Thank you, ma'am. I know it is too much to deliver in one session.
No.
And we can have
okay, there is one
more...
query. Yeah, sorry to interrupt you. This is by Dr. N. Maria Jose. Can we use data science tools and techniques to mitigate cyber crimes?
Yes, Maria ma'am, in fact, data science techniques are already being used. For example, when you get an email, have you noticed that for some emails, Gmail says that this may be a potential spam email? So don't open it, or don't click in it, or use it only when you know the trusted source. So if there are certain words that are there in the email, in the language of email, or if it is being sent to a lot of unknown contacts in bulk, then automatically, they filter it out. So similarly, some precaution have to be also taken at our end, but slowly and gradually, from basic email filtering, spam filtering, to different applications they are trying to develop. In fact, this blockchain technology can help in securing things, and there's system of double and triple authentication in fintech, so you can be prevented from cyber crimes.
So the next question is by Dr. Franklin. There are any tools for financial planning or analytics?
Yes, Dr. Franklin, sir, we can use some tools. So basically, for financial planning part, the kind of Excel template that I showed to you, they can be developed by yourself, or you can take some help. And uh, if you want, I can share that Excel template which I showed to you. So there are some good templates available for financial planning, and in which you can again input these things like rate of interest, rate of inflation, reinvestment rate, time horizon, initial investment amount, target amount, and you can find out the calculations. And for good references, I think I will share the PPT with organizers, and they can pass on to you. And in the last few slides, you can see the references for these.
And one more question by Dr. Franklin only. Good sources to learn data science online.
Online, there are many, I think, YouTube channels. See, I am a old school person. I like to read from books. I don't I don't like to read much from, but there are some sources. For example, there is machine learning repository or GitHub. So if you look, because I am slightly skeptical of many online things. Sometimes they are not authentic and they keep on changing. They can be gone any day. So I prefer, and especially when you are getting into a new domain, so either you go with trusted speakers or experts whose video sessions you can see, or you go with good foundational books to get started with, from where you can learn programming and applications, and then you can go. Because if you, then you can, I think, go to a website, because a website will not provide you that thorough foundation. They will have topics and separate and brief introductions, and especially since we are instructors, either see, since you are already a PhD, so either you are already a faculty or you want to be a professional. So in either case, you won't pass on. We can't strive by like students they do to pass exams. We have to have thorough detailed knowledge.
And Seema, ma'am, yes, we are going, the YouTube session, the YouTube link for this session will be posted. Yes. And that's it. There is no other query on the chat box. So anything, any doubt anyone wish to ask can post. So I think there is no other doubts, which I think possible.